Thank you for attending my session. I'm Yuichi Nakamura from Hitachi. Today, I'd like to talk about authentication and authorization about AI agents. First, let me introduce myself. I am Yuichi Nakamura. I'm leading OSPO of Hitachi, and also I have a lot of role in open source community. I'm a Japan evangelist and board of the Linux Foundation and governing board of CNCF. I have been working with open source community more than 20 years. My first contribution started from SE Linux, and recently I'm focusing on Keycloak and CNCF open sources. And as a board of Linux Foundation and CNCF, I am connecting various communities with each other. Today, I'd like to connect you to CNCF open source Keycloak. First, I'd like to introduce MCP and authentication and authorization. This slide shows a very simple overview of AI agent. AI agent act as a user, work autonomously on behalf of user using LLM and communicating with external tools like database and file system and API. These tools are very important to generate correct answer. And AI agent get latest information from external tools. And there is a problem in talking with tools. The interface is diverse. For example, database is SQL, file system is command line, and API is REST. It is very inconvenient to develop AI agent because AI agent have to use various protocols. For such problem, MCP, Model Context Protocol, is here. In AI agent, there is a MCP client, and in front of tools, there are MCP servers. MCP client and MCP server talk to each other by MCP. MCP is standardized in open source community. It was originally developed and opened by Anthropic, but now its governance is open, and there are maintainers other than Anthropic. To use AI agent in production system, authentication and authorization is essential. Because in tools, there are very privacy information and secret information is stored. To prevent information leakage, authentication and authorization is necessary. For example, user has to authorize to access their data to MCP client, and before that, user and agents have to be authenticated, and to access and in MCP server, unauthorized access must be blocked. For authentication and authorization of MCP, a framework called Auth 2.0 is used. Auth 2.0 is standardized in IETF. It is a framework. It has been widely used for authentication and authorization for REST API, and MCP also adapt Auth 2.0. This figure shows the flow, very simplified flow of OAuth 2.0. Users access authorization server at first. Authorization server authenticate user and client, and it also shows consent screen and user authorized access. And after that, authorization server issue access token to MCP client. And MCP client issue request to MCP server with access token. MCP server verify access token and make authorization decision. And after that, MCP server returns result to MCP client. Here, access token is a key data, and authorization server that issue and manages is very important. And in OAuth 2.0, there are a lot of freedom to implement. So there are a lot of security holes found in improper implementations. If access token or intermediate data called authorization code are stolen by attackers, attackers can act as a user, and information is stolen. And to prevent improper implementation of OAuth 2.0, there are a lot of practices are stored in IETF in this RFC, best current practice for OAuth 2.0 security. Based on this best practice, OAuth 2.1 is being specified in IETF. It is still draft, but is now adopted by MCP. In OAuth 2.0, some extra parameter checks are mandated called PIXI, and some additional checks to prevent open redirect and other security holes are mandated. Authorization server that comply with OAuth 2.1 is necessary for MCP. As an authorization server complying with OAuth 2.1, I'd like to introduce Keycloak. What is Keycloak? Keycloak is an open source implementation of identity and access management, IAM, and Keycloak is now CNCF incubation project. Keycloak has various features, identity management and authentication. Keycloak supports various types of authentication, like two-factor authentication and passkeys and social login. And Keycloak has comply with a lot of standards such as OIDC and SAML, and OAuth 2.1 and OAuth 2.0 and others. Keycloak works as an authorization server complying with OAuth 2.1. But why Keycloak? There are a lot of IAM, open source IAM implementation. The first reason is Keycloak is very popular. Keycloak is a CNCF project, and its GitHub star is about 30,000. Second reason is Keycloak is widely used in production in mission-critical systems. Keycloak is used in banks, especially used in open banking in Europe and the UK, and Rails. As you may noticed, if you reserve seat in Deutsche Bahn, there is a login screen. It is Keycloak, I found. And Keycloak is used various governments. Japanese government is also using Keycloak. And the utility is using Keycloak. My Japanese utility customer is using Keycloak. Third reason is Keycloak community is very, very active. And this left figure shows the velocity report of Linux Foundation projects. The velocity of Keycloak is very high compared with other projects. There are a lot of contributors. And about the development Auth, Auth 2.1 and Auth is evolving every day. So we have to catch up the latest standard and best practices. There is a community in Keycloak, Auth Auth is catching up Auth-related specifications timely. Auth is reporting a conformance report to Auth-related specifications. And this is a report you can see in the GitHub. Recent Keycloak is conformant to major security profiles about Auth 2.0. To use Keycloak as a Auth 2.1 authorization server, administrator have to configure Keycloak correctly. For example, configure to enforce PXE and some checks. To help configuration, Keycloak has a feature called client policies. In client policies, there is a feature called profile. It is like a configuration template. A profile for Auth 2.1 is prepared. This is a management console of Keycloak, and this red square is a template for Auth 2.1. And just applying this template, you can configure Auth 2.1 authorization server easily. And this figure shows simple integration pattern of Keycloak for MCP authentication and authorization. Keycloak is an authorization server. At first, this is a flow of the Auth 2.1 flow of authorization code grant. MCP client requests MCP server, and MCP server redirects to Keycloak. Keycloak shows login screen and consent screen. After that, authorization code is issued to MCP client. MCP client issue token request to Keycloak. And Keycloak issues access token to MCP client. And MCP client request to MCP server with access token. And here MCP server verify access token. To verify access token, MCP server issues introspection request to Keycloak. Keycloak verify access token and returns the result. If the result is true, MCP server decide access based on access token. Look at the contents of the access token, check the user and role and other properties. And if all okay, MCP server access the tool in behind and response MCP response. There are some issues in this simple integration pattern. First one is URI of Keycloak metadata endpoint. Before the request, MCP client obtain metadata from Keycloak, but the URI is not compliant with MCP. Second one is implementing this verification process. If there are a lot of MCP servers, it is not easy to implement this check correctly. This is about the first problem. Keycloak's metadata URL is upside here. And below is expected metadata in MCP spec. It is compliant RFC 8414. After hostname .wellknown comes, but Keycloak metadata endpoint is not such form. To resolve such problem, it is very convenient to use reverse proxy, such as Nginx and API gateways. Many reverse proxy support plugin. We implement workaround and access check in here. About the first problem, this reverse proxy converts a URL convention. But this workaround will not be required. My colleague submitted a pull request to comply with RFC, and this pull request was merged last week. So in next version of Keycloak, this workaround is not necessary. And the verifying access token and the access control, we usually implement it in the plugin of reverse proxy. Verify access token, issue token introspection request, and check the contents of check user and roles and other properties associated with access token. Next, I'd like to introduce a high-level security feature called FAPI. Auth 2.1 is developed by bottom-up approach. It is developed from best practices. And there is no way to verify conformance and interoperability. In Auth 2.1, there is no conformance test. FAPI is a specification to secure API on top of Auth 2.0 by OpenID Foundation. It was called originally financial grade API in version 1.0. It is widely used for banks, for open banking projects all over the world. In version 2.1, it is renamed as FAPI for general purpose. This FAPI 2.0 covers Auth 2.1, and so can also be used for authentication and authorization for MCP. This slide shows the features of FAPI. First feature is high security. FAPI 2.0 is developed based on attacker model and mathematically formally verified. There are a lot of academic papers to formal verification of FAPI. Requirements are very similar to Auth 2.1. It covers Auth 2.1, but it is more strict. For example, to prevent usage of stolen access token, binding access token to client is must in FAPI. It is should in Auth 2.1. And crypto algorithms are strictly specified in FAPI 2.0. And some other points are more strict. And the most important point of FAPI is interoperability. OpenID Foundation provides conformance test suites and conformance program, certification program. By using conformance test suites and conformance program, we can have interoperability. FAPI, this slide shows the status of FAPI in Keycloak. Keycloak now supports almost all features required for FAPI 2.0. Last week, the final pull request was merged. So in next version, Keycloak pass conformance test, and also client policies, this is a template, is prepared for FAPI 2.0. To keep conformance, I said Keycloak community is issuing conformance report. To issue conformance report, Keycloak community is using conformance test execution environment, as shown in this figure. And maintainers use this test suites in every release of Keycloak and reporting conformance to public. Yeah, finally, I'd like to introduce Keycloak community, Authz SIG. Authz SIG is a community inside Keycloak. It is discussing about a topic all about Auth. Recently, the hot topic is topics related to AI agent, how to use Keycloak for MCP and A2A. Tech lead is my colleague, Norimatsu-san from Hitachi OSPO. And monthly meeting is held. You can, the minute is public. And the meeting URL is announced in CNCF Slack channel, this channel. So you can join Slack channel from this invitation link. And let's join this Authz SIG Slack channel. Okay, thank you very much. If you have, thank you. And any question? Mike.
Thank you, Nakamura-san, for the presentation. I would like to ask you, so you had a slide where you showed different ways that we can connect and get data from existing systems. So you had SQL interface, CLI, REST interface. And then you showed to us that we are using MCP servers, right? Yeah, exactly. So the agent, it's now connecting to different MCP servers. My question is, when we think in different tools that we use for power systems, they are databases, file systems, APIs, and so forth. Going forward with agents, will we replace those interfaces, SQL, CLI, REST, with an MCP server, or MCP server will be an extra interface that those tools needs to offer for Agentic AI?
Your connection is where to implement and where to implement the this such protocol. Yeah. Usually we implement in MCP server inside the MCP server. So there are a lot of open source is appearing to support implementation of MCP server.
So do you think that all the tools, let's say we have like Panda Power, for instance, in the future there will be an MCP server connected to Panda Power, so as agents can connect to Panda Power via the MCP server?
Yeah, and this figure there are 3 MCP servers, but in real system there is only 1 MCP server as a reverse proxy and implement such conversion. Yeah.
Okay. Thank you. Else?
Okay, ですか? Okay. Okay.
Yes, we know that sometimes these large language models can hallucinate. What are the risks of giving this authorization to, in this case, agents that use these large language models to have access to APIs or to have authorizations? Maybe with the other kind of tools that they will also use, we can verify that it's secure, that they don't make requests that are maybe unsafe.
Sorry, I'm not understanding your question.
Okay, sorry. Yes, I was going too fast. About the risks of giving these authorizations to agents. What is your opinion?
Agent to agent?
Agents to databases, for instance, or
Sorry, I'm not sure. Okay. Yeah, let's talk later. So sorry,
yes,
I'm
they
not
have,
understanding.
with these authorizations, they can have access on behalf of the user. And what about the risks of giving them this access?
Sorry, I don't want to have answer for now, but yeah, let's discuss later. Sorry.
Okay.
Yeah. Okay. Okay, thank you very much.